Good afternoon, guys. Good afternoon, and we are live with some exciting new content that we have started today. It's solve a problem a day to keep the exam fear away. So it's a motivate. It's like a action to help and motivate the students to solve problems regularly. Okay, for whatever exams they're preparing, for whatever like concepts they're building and build their foundation. So today's problem, 25th August ka problem is this, that in how many ways you can see the problem on the like screen. The problem is the following: in how many ways you can select 6 letters out of 100 A's, 80 B's, 60 C's, 3 D's, 2 E's, and 1 F. Okay, so this is a problem. So you have 100 A, 80 B's, 60 C's, 3 D's, 2 E's, and 1 F. So let's understand how we can do this problem, like how we can approach this problem, and how we can mathematically model this problem and use our foundation combination knowledge to solve this problem. Okay, this will take a bit of time because it requires some understanding of basic understanding. So let's get started, guys. Um, let's think about this. So let's think about this problem in this way. Okay, in the way that you have six places. You have to take six balls. Okay, you have to take six balls out of this, and in A there are 100 balls, and in B there are 80 balls, in C there are 60 balls, and in D there are 3 balls, and in A there are 2 balls, and F container there is one ball. Okay, so the idea is that you have to pick 6 balls out of this. So one way to understand is the following, that one how many ways you can pick that. So let's say one can be 2 A's from here, one B from here. Okay, one C from here, sorry, one C from here, one D from here. Okay, कितना हो गया? 5 and 0, nothing from here, and only one F from here. This can be one such case, right? So now let's try out other cases. Okay, I'll give you 15 seconds to think about it. Okay, let's try out some other cases. Fine. Great. So let's try out. I think you have tried out other cases. So let's try out other cases, like there can be 4 A's, no C, and just 2 E only. Okay, so that's also 3 cases. Six such um possible outcomes. Six such. That's one way of explaining that. Okay. So now let's try to think. Let's try to think how to generalize this problem. So essentially, it means that if you take other cases, what it essentially means that you're taking certain number of balls from the A counter, certain number of balls from the B counter, certain number of balls from the C counter, certain number of balls from the D counter, certain number of balls from the E counter, and certain number of balls from the F counter, such that the sum is 6. That's the idea. So the sum is 6, and you know this problem. You can go and see the like the thumbnail of this YouTube video to get the problem. Okay, so that you can see the problem while you're doing the seeing the solution with me. So understand this now, that what you're trying to do. You're trying to therefore see how many balls are coming from A, how many balls are coming from B, how many balls are coming from C, how many balls are coming from D, how many balls are coming from E, how many balls are coming from F, such that the sum is 6, right? So how to do that? So let's try out an easier version of this problem. Let's try out an easier version of this problem, where let's say, so essentially the problem boils down to the following aspect, that you need the solution of A plus B plus C plus D plus E plus F is equal to 6. Okay, these are all the number of balls you're taking from that counter. Okay, counter A, counter B, the number of balls you're taking from that counter, such that with the constraint that A is less than equal to 100, because there are 100 at most balls of A, B is less than equal to 80, C is less than equal to 60, D is less than equal to 3, E is less than equal to 2, and F is less than equal to 1. This is the idea. Okay, so we need the number of solutions. Also, we need A greater than equal to 0, B greater than equal to 0, C greater than equal to 0, D greater than equal to 0, E greater than equal to 0, F greater than equal to 0. So in this case, what you understood over here, two it was 2 here, 1 here, 1 here, 1 here, 0 here, and F here for the first one. For this one, it's 4 here, 0, it's 4 here, 0, 0, 0, 1, 2 here, and 0. So all of these are different ways of solutions, okay? Number of solutions. So we are trying to find out the total number of solutions of the equation where this AI, A, B, C, D's are all integers, okay? That is the main criteria. So we want to solve this in positive integer solution, in non-negative integer solutions with these conditions, okay? So this is our aim. This is what we are aiming to do. But let's do the problem for an easier version. Let's try to do the problem in a different way. Okay, we will see something like this will be coming up. But let's do an easier problem first. Let's do the problem of this. And let's say A plus B is equal to 5, and we have A less than equal to 2, greater than equal to 0, and B less than equal to 4, greater than equal to 0. Okay, such that we want to find this, and you know the only solution you can find out is 1, 4, nothing more, right? There's only one solution. So let's try to find out. Let's try to find out how you can do it in a different manner. I will tell an algorithm so that you can solve any kind of problem like this. Let's try to understand the algorithm. So let's do something magical. Okay, let's do something magical out of the blue. So let's take this. So you have 2 over here and you have 0 over here. So let's start with this 0. Let's start x to the power 0 and continue to x to the power 2. That is plus x1 x to the power 1 plus x to the power 2. Okay, this 2 multiplied by this here. So let's continue with x to the power 0 for the 0, and let's continue till x to the power 4 plus x to the power 1 plus x to the power 2 plus x to the power 3 plus x to the power 4. This 4 comes from this region, this portion. Okay, let's try to do this, and let's multiply this. So when you multiply this, what do you get? You will get 15 such elements. So let's write out those 15 elements. It will be a bit hectic, but I'm ready to do the hard work for you. So let's do the 15 elements. So it's first one is x to the power 0 plus 0 for this. The second one is x to the power 0 plus 1. The third one is x to the power 0 plus 2. The fourth one is x to the power 0 plus 3. The fifth one is x to the power 0 plus 4. Okay. Then what is the next one? X to the power 1 plus 0. X to the power 1 plus 2. X to the power 1 plus 3 plus x to the power 1 plus 4. I'm missing something. Yeah, I miss x to the power 1 plus 1, x to the power 1 plus 2, x to the power 1 plus 3 plus x to the power 1 plus 4. Okay, let's do for x to the power 2 also, plus x to the power 2 plus 0 plus x to the power 2 plus 1 plus x to the power 2 plus 2 plus x to the power 2 plus 3 plus x to the power 2 plus 4. So we have written down all the 15 elements that are possible. We have written all the 15 elements that are possible. Let's see the connection. So if you sort of think that this is A, this is the A, all these are A and all these are B. Okay, all the possible values of B. Okay, so let's see, this is what? Here it's telling it's A is equal to 0 and B is equal to 0. Here it's telling A is equal to 0 and B is equal to 1. Here it's telling A is equal to 0 and B is equal to 2. Okay, so understand that if you add this up, what will you get? Let's add this up. Let's write it down properly. And you will get that it's x to the power 1 plus x to the power 1 plus x to the power 2 plus x to the power 3 plus x to the power 4 plus x to the power 1 plus x to the power 2 plus x to the power 3 plus x to the power 4 plus x to the power 5 plus x to the power 2 plus x to the power 3 plus x to the power 4 plus x to the power 5 plus x to the power 6. Am I doing some mistake? No, I'm not doing some mistake. Yeah, sorry, there are two solutions, 2 comma 3 and 1 comma 4. Only two solutions are there, right? So we'll see the two solutions coming out magically. Now let's see that how many x to the power 5 are there. So if the first one represent the value of a and if the second one represent the value of b, so let's look for where x to the power 5 is coming. So x to the power 5 is coming here and x to the power 5 is coming here, right? So there are two values coming up, x to the power 1 plus 4, x to the power 2 plus 3. The two values coming up. So what we are getting? We are getting that there are two x to the power 5 coming up. So what is the basic idea? So if you add it up, you will get that how many x to the power 1 is there? 3x 1 is there. Or there is x to the power 0 is 1, x to the power 0 is there. So 1 x to the power 0 is there. Plus, it's done. So 2 x to the power 1 is there. Let's say x to the power 2. X to the power 2 is 1, 2, 3. 3 x to the power 2 is there. Are there. X to the power 3 is 1, 2, 3. 3 x to the power 3 are there. 4 are 1, 2, 3, 4 plus 2 x to the power 5 plus x to the power 6. So if you observe that there are two solutions and that's exactly the coefficient of x to the power 5, right? That exactly the coefficient of x to the power 5. So what we are getting? We can get a connection between adding this up and finding the coefficient. So what we got that if we need to find the solutions of this with the given condition a is less than equal to 2 and greater than equal to 0 and b is less than equal to 4 and greater than equal to 2, greater than equal to 0. So what we do is that the step 1 is that we multiply x to the power 0 plus x to the power 1 plus x to the power 2, right, into x to the power 0 plus x to the power 1 plus x to the power 2 plus x to the power 3 plus x to the power 4, where 0 is here, 2 is here, this 0 is here and this 4 is here. And then what we do? We compute the coefficient of x to the power 5, this 5. That is exactly the number of solutions to this equation. That is coming out to be 2, which is true. And I have explained you why. Because x to the power, if you just add this up, essentially it's like a plus b, right? Where a is varying between 0 and 2. See, if a is varying between 0 and 2, and b is varying between 0 and 4. The multiplication of this is exactly like a plus b is equal to 5. A plus b is like x to the power a plus b, where a is going through this and b is going through 0 to 4, and a is going through 0 to 2. So this is the basic idea. So this is something really interesting. This is something related to something called generating function, but I'm not going to the details, but this is an algorithm. You can think about this algorithm. You can think that how much powerful it is. Okay. And you can use this algorithm to solve this problem. And we have got that x to the power 5 a coefficient is coming out to be 2. So similarly, let's extend this idea to this problem. To extend this idea to this problem, so we have what? We have a plus b plus c plus d plus e plus f is equal to 6. And we have the following condition that a is less than equal to 100 and greater than equal to 0. B is less than equal to 80 and greater than equal to 0. C is less than equal to 60 and greater than equal to 0. D is less than equal to 3 and greater than equal to 0. E is less than equal to 2 and greater than equal to 0. And F is less than equal to 1 and greater than equal to 0. We have these following conditions. So how will we make the multiplication? So we will make the multiplication like this. For this, we have x to the power 0 say plus 1 around x to the power 100. For this, we will take x to the power 0 plus around x to the power 80. For this, we will take x to the power 0 for the first one, dot dot till x to the power 60, since it's the maximum possible case. And for the final one, we will get x to the power, for D, we will get x to the power 0 plus dot dot x to the power 3. For this, we will get x to the power 0 plus x to the power 1 plus x to the power 2. For this, we will get x to the power 0 plus x to the power 1. Now what we'll do, we'll multiply all this. We'll multiply all this. So let's write it down in a beautiful way. You can write it down as x to the power 101 minus 1 by x minus 1. Here x to the power 81 minus 1 by x minus 1. Here you can write x to the power 61 minus 1 by x minus 1. Okay, here x to the power 4 minus 1 by x minus 1, x cube minus 1 by x minus 1, and here x square minus 1 by x minus 1. You can write it like this, right? And what we need to do, we need to multiply all this up and find the coefficient of what? Coefficient of x to the power 6, because 6 is the idea over here. 6 is the final sum over here. Coefficient of x to the power 6 after multiplying this. And I have explained to you how this is coming up by this short example. Okay, so similarly, let's do this. And after doing this, you will get the following. So you're multiplying x to the power 0 plus x to the power 1 dot x to the power 100 times x to the power 0 plus x to the power 1 dot x to the power 80 times x to the power 0 plus x to the power 1 plus dot x to the power 60 times x to the power 0 plus dot x to the power 3 square times x to the power 1 plus x to the power. When you multiply this, the outcome of this, the expression of this, uska x to the power 6 ka coefficient is exactly the answer we are looking for. And what we get? We get that it's equal to, how do you find this now, x to the power 6? We'll use the expansion now. We'll use binomial theorem now. And let's try to understand that. It's really beautiful. So first one is this, right? X to the power 100 minus 1 by x minus 1. The second one is x to the power 81 minus 1 by x minus 1. The third one is x to the power 60 minus 1 by x minus 1. The fourth one is x to the power 4 minus 1 by x minus 1. And the x to the power 3 minus 1 by x minus 1. Into x to the power 2 minus 1 by x minus 1. Right? This is what we have. Now, uska multiplication is like this. It's x to the power 100 minus 1 times x to the power 81 minus 1 into x to the power 61 minus 1. We are using what? We are using the result that 1 plus x plus other x to the power n is equal to x to the power n minus 1. You are using the GP series, okay? It would be GP series result. And we get this times, this is the most important part, time x to the power minus 1 to the power minus 6. Okay, so we will use now the general like binomial theorem over here. Okay, so this is what we have got. This is what we have got. Out of this, we need to find out the coefficient of x to the power 6. That is the thing we are required to find out. Right? Let's understand the whole thing we developed. We try to find the coefficient of x to the power 6. And let's see that when you multiply this term, and this term has no effect on coefficient of x to the power 6, because uska coefficient is more than x to the power 6. So this term has no effect on coefficient of x to the power 6. So let's delete this part. Okay. So this has no effect on this. So let's delete this part. So essentially, we need to find out the coefficient of x to the power 6 in x, because whatever the coefficient is, it will come out here only, and by minus, like by one multiplication, you will get that. Okay, so it's like x to the power 4 minus 1 into x to the power 3 minus 1 into x to the power 2 minus 1 into 1 minus x whole to the power minus 6. So out of this, you have to find the coefficient of x to the power 6. So how to do this? Let's think about it. So let's first multiply this part. So you get x to the power 7 minus x cube minus x to the power 4 minus 1 into x square minus 1 into 1 minus x whole to the power minus 6. Let's multiply it again. So you get x to the power 14 minus x to the power 6. Sorry, yeah, minus x to the power 5. Sorry, there are other cases also. X to the power 4, not 9, sorry. And then x to the power minus 7. Then x to the power minus 5. Then x to the power 4. Yes. So let's write it down properly. Let's write it down step by step so that I don't do a mistake. Minus x to the power 5 plus x cube minus x to the power 6 plus x to the power 4 minus x square plus 1 times 1 minus x whole to the power minus 6. So you get x to the power 9 minus 7 x to the power 7 minus x to the power 6 minus x to the power 5 plus x to the power 4 minus x plus x cube minus x square plus 1 into 1 minus x whole to the power minus 6. So therefore, it turns out that we need to find out, so we have found out this, we need to find out the coefficient of 1 minus, so the expansion of this, okay, till x to the power 6 maybe, till x to the power 6. So let's find out the expansion of this. 1 minus x, sorry, it was I think x minus 1. I did some mistake, x minus 1, I did reverse it. It was x minus 1. So what we do is the following. Let's do x minus 1, x minus 1, x minus 1, x minus 1. So when you do x minus 1 whole to the power 6 ka expansion, how to do it? Use binomial theorem. We use binomial theorem. So how do you do it? There's a specific way of using it. So let me just copy and paste the general binomial theorem. Binomial theorem, general statement. General formula if I do for real numbers. So let me just copy and paste it from Google so that it becomes easier for you. I think it's called Newton's binomial theorem. Yes. So if you see over here, you will see that how it is done. It's really interesting actually how it's done. So let's try to find it out. Let's try to find it out. And how to exactly do it. This is a really interesting way of like this is an interesting application of how you can use this property to really. So Newton's okay. Let's write down the whole thing. So Newton's binomial theorem tells the following. Is the following. So what is R choose I? R choose I is the following. R choose I is the following. It's defined like this. There's no factorial over there. R is a real number. Okay. So it's defined like this that R choose I is defined like this. It's a very special case. R choose I is defined like this. So you can write this as like what? You can also write it as 1 minus x whole to the power minus 6. Why? Because this is same as what? 1 by x minus 1 whole to the power 6. It's 1 minus x minus 1 whole to the power 6. It's equal to 1 minus x whole to the power minus 6. Okay, it's turning out to be this. So therefore, you have minus x over here. That's an issue. But let's understand it. So we have to find x with 1 minus x whole to the power minus 6. So let's expand it. So we will expand till x to the power is 6 because that's what we need. We'll expand it till x power is 6. So we'll get R choose 0. R choose 0 means there's nothing. It's always 1. Okay. R choose 0 is 1. But let's write down. R choose 0 means R choose I means there is nothing over there. So it's 1 plus R choose 1 x to the power I. So minus x होगा वहां पर. So R choose 1 means R into R minus 1 by 1 factorial. R is a real number. So what is R over here? So R is 6 minus 6 over here. So minus 6 times minus 6 minus 1 by 1 factorial into minus x whole to the power 1 plus minus 6 into minus 6 minus 1 into minus 6 minus 2 by 2 factorial into x to the power 2 minus x whole to the power 2, which is x to the power 2. Similarly, you can write it down. Okay, similarly, you can write it down and you will get the following. Okay, you can add this up. This is the homework for you. Complete this up. You can write like this. Let me do another one. Minus 6 into minus 6 minus 1 into minus 6 minus 2 into minus 6 minus 3 by 3 factorial. I think I'm doing something wrong. Yes, I am doing something wrong because there is only one. So it will be minus 6 this. It will be minus 6 and here it will be just without the 3 part. Yes. Into x to the power minus x to the power 3 plus dot dot dot. It will continue. So let's see what we will get finally. So if you write it down, you will get the following result. Okay, I have done it before, so I'm not doing it. So you will get the following result. You will get 1. So it's minus 6 into minus x. So it's plus 6. So you will get 1 minus x whole to the power minus 6. You will get 1 plus 6x. Let's check it out here. Minus 6 into minus 7. Minus 6 into minus 7 by 2. So it's turning out to be 42 by 2, that is 21 x square. So you get 21 x square. Okay, and you add it up. Here you get, so if you see it's minus 8, there's a minus over here. So essentially what you get over here is the following, that you get 1 plus 6x plus, you see it's 7 into 6 by 2. So 7 choose 2. It's 6 choose 1 actually into x. Plus 7 choose 2 plus x square plus 8 choose 3 into x cube plus 9 choose 4 into x to the 4 plus 10 choose 5 x to the power 5 plus 11 choose 6 x to the power 6 plus a dot. We don't need more than that because we need to find out the degree of x, the coefficient x to the power 6. So that's what we get over here. Okay, that's exactly what we get over here. And if you just multiply it with the corresponding this, you will see that how many x to the power, so how many x to the power 6 ka coefficient will come up. So you will make that x ke saath 1 ke saath you will get, so let's write it down over here. So let's say you have got, you're multiplying 1 plus 6x plus 21x square plus 8 choose 3x cube plus dot dot dot. Okay. So for one, with 1 you will get comment. So these are not important. So for with 1 you can this one minus 6. So it's minus 1 minus 6. Okay, and you can add it up all of this till 1 till x to the power 6 coefficient to get the coefficient of x to the power 6. Okay, using the same algorithm, and you will find out the coefficient of x to the power 6, and you will find out it will turn out to be 266. Okay, so that's the end of the problem. But you can understand that this is a really interesting idea, and that's why it's given in the solve a problem a day. And how you can use this to in fact generalize this problem to any constant any constant summation, like constant formula like this. Okay, constant problem like this, where you can not only give 0, you can give any 5, any 10, whatever it is you want. Okay, and that is a really super powerful method. This is a generating function method, and I hope you understood it. I hope you enjoyed it, and if you liked it, please do share with your friends and tell the friends to solve the problem for a day and let them see the solution. Okay, All the best, and yeah, for any other information, you can check the description. Check the description for the other problems of the other weeks. We are updating it regularly, and yeah, all the best, guys, and have a good day ahead.